appreciate this opportunity to give you an update on, what we've done the last few years. So let me see if I can share this here. Do you see my screen?
Yes.
Good. So updates, and this is not just me, but I have a group. We're almost close to 10 people, a fabulous group that's very highly motivated and loves the work we're doing here all together. So they're all shown here. This picture, you see the names, but I'm the one who's going to present this today. Let me see if I can. Yep. So, this presentation and most of the work we're doing focuses here on the Colorado Front Range. You probably recognize this map. All these dots there, including the colored ones, are locations of oil and gas wells in the Denver-Julesburg Basin. There's some 25,000+ wells here in the area, and that has triggered development of this monitoring network. And this has been funded by local governments pretty much exclusively. They're listed here: Boulder County, City of Longmont, Town of Erie, and Broomfield City and County. So thanks to all of them, I've been supported this monitoring program. These axes on this map show the locations of these monitoring stations that we've set up. So you can see they're mostly on the western skirts of this extensive area with these abundant oil and gas wells. That's driven by, that's where the communities are that funded this program. This is where lots of people live who are concerned about oil and gas pollution. But it's also really good locations from a scientific perspective, since we mostly see airflow from the east to the west. So these communities here on the western edge of the basin end up with a lot of the pollution, because that's what it's blown to by the prevailing winds. So you can see there's 2 stations in Longmont, there's one in Erie, one in Boulder Reservoir, and then there's 2 in Broomfield. Let's see. This is how these stations look like from the outside. So they're small shelters that are climate controlled, have heat and cooling, and there's a tower next to them that supports equipment. And some of these are semi-mobile trailers, other are fixed buildings. And you see the names where these are located. Oops, I'm still figuring this out. And looking inside of one of these instrument shelters, you have some pictures here. What I want to emphasize that this is all high research grade, or we call it regular grade equipment. So this is equipment, and we follow protocols that are fully approved by regulatory agencies such as EPA or the state. All the data we produce here is of high quality and meets publication requirements. Everything runs fully automated around the clock. It runs every day of the year. And also, I want to emphasize, we're not just a contractor who provides numbers and monitoring data, but we're a group of scientists who work with the data, do interpretations, write publications, and try to communicate these as well as we can to the public and the sponsors. And part of this communication takes place through these web portals. We have several of those. Each program has a dedicated web portal that reports the data and all kinds of supporting information and data interpretation. And they're constantly watched and improved and maintained by us. And we're pretty proud how well these have been embraced by the community, and we count the site visits, and there are well over 100,000 visits we've gotten on these different sites reporting atmospheric composition data. That's just another example of one of these websites. It's a screenshot from the Longmont websites that shows how concentration data for some of these pollutants that we monitor are on this particular tab reported, as we call this time series that show the changes in concentrations by day and by hour for just 3 selected species of the many other ones that we monitor here. So today I want to focus on something that's new that I haven't reported on too much before. 4 topics. First one is ozone updates, wildfires, show you the latest scientific publications that we've developed out of these data. And then something we're working on right now is to look at trends in these pollutants. So I'll start out with ozone. I'm pretty sure you all know this. We are in what's classified as serious and as severe. There's actually 2 standards that the EPA watches for ozone concentrations. And for one of them, I think we're classified as severe, the other one for serious non-attainment area. In the United States, because we have been exceeding the ozone health standards for many, 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 many years, and it hasn't gotten better, and that has caused us getting downgraded in several steps. And you see, we're not alone. There's other areas in the United States that are in non-attainment, but you also see that, most of the country has better ozone, cleaner air than what we have here in the Front Range. Okay, so ozone, again, just to make sure there's no confusion, is not released, it's not emitted by industries, but it's formed in the air through chemical processes. But what's formed is ozone, that's what we're emitting, releasing in the air. And the 2 important classes of compounds that built into this are volatile organic compounds and nitrogen oxides. And that's what we're doing here. We're emitting too much of those, which then causes too much of ozone in the air. This is, sorry, I have a visitor here. I have to put my cat down because it's blocking my monitor. So this is a record of the ozone observations here at the stations that we're maintaining over the past 7 years or so. So you see, ozone is very dynamic. It goes up and down every day. All just changes with season. We have much higher ozone in the summer typically than in the winter. You can see it really changes from year to year. It's really hard to tell. Is it getting better? Is it getting worse? This certainly doesn't look like it has gotten any better. The different colors here are the data from the different monitoring stations that came online at different times. But you see, last year was no better than 6-7 years ago. To look at just last year in particular, so this is the ozone record for 2004, the summer of 2024. This is actually the ozone recordings that we take pretty much every minute. It's averaging them over 8 hours because that's how the EPA monitors compliance with these standards. So you can see it's actually pretty consistent between these different stations because ozone is a pretty evenly distributed pollutant that we're all encountering together here in the Front Range. It's not much worse or much better in Longmont versus Erie versus Boulder. And we're all getting about this very similar ozone. And the count for last year was that this standard was exceeded on 27 days. So 27 days of the summer, we had ozone that was in non-compliance with the EPA standard. And in order to get back into compliance with the standard, to be in attainment, we would need no more than 4 days on average. So, if you have more than 4 days on average above that standard, you're non-compliance. You can see we have a long, long ways to go to reach compliance with the ozone standard. Something else that's been on our mind and that I'm sure that you've seen and worried about are these wildfire smoke events. So that's my second topic here. This is 3 years of particulate matter recordings from 3 stations. So that's Longmont, that's Erie, and that's Broomfield, these different colors. And these are the 24-hour average data. So that smooths out a lot the spikes that we see on shorter time scales. But what you see here is that, not regularly, but every so often, we encounter these fire events where the loading in the atmosphere with these particulates exceeds what's currently defined as the National Ambient Air Quality Standard for these fine particles, which is 35 micrograms per cubic meter. So I've some of these events highlighted, and you may remember them. So there were quite a few days over the years where we exceeded that air quality standard because of wildfire smoke. But a remarkable exemption is that photochemical winter smoke event here in March 2021. That was not wildfire. This was a winter inversion situation. It was very unusual, and I'll get back to this later. And that was clearly related to oil and gas pollution occurrences, and also an ozone exceedance, which is very unusual this time of the year. To show you a little bit more what we're encountering on these wildfire smoke days, I'm looking into this particular event here in May 2023 with the next slide. On the upper trace, you can see zoomed in the change in particulate loading in the air. Prior on May 18, we had levels that were single digits, micrograms per cubic meter, which is what we usually have here. And the picture below, we take these webcam images every 30 minutes at all of the sites and look at those later if we see something interesting, as we did here. So it's pretty clean. It's clear, nice views. And then as this smoke event hit us, and you can see all three sides, it got up, but it got up a little bit earlier at Longmont because the smoke came in from the north. It hit Longmont first. The purple here, pinkish, goes up, and then half an hour later, Erie follows, and then Erie. But they all max out at very similar levels. So the whole area was just loaded with these particles and reached very similar maximum concentrations. You couldn't run away from it. You couldn't ride your bicycle away from it. You really got to travel long ways to run away from this. You can see the picture on the right side. Now we're having 110 micrograms per cubic meter during this wildfire event, and it lasted several days. And that was ways exceeding the air quality standard, which is 35 micrograms per cubic meter. So we hit 110, and 35 is the standard. Very, very poor air quality. But what we see the particles. You may smell something. You may smell the smoke. So there's more than just the particles. So with these extensive measurements we're taking, we actually have information on ways more pollutants. I want to give you a few examples here. Again, in the upper trace, this is the particulate matter, say, relatively low in the beginning, then it jumps up when the smoke hits us. And below now is one of these many gases we monitor, and this is ethene. This is a hydrocarbon, and these are data from 5 different of the stations where we're running this, and you can see the very consistent results showing that as the smoke front hits us, ethene goes up by about a factor of 10 from levels that are usually 0.2, 0.3. A little bit of wiggle there, it goes up well over 1.5 to 2.5. It stays high right while we're sitting here in this soup of smoke. So it's not just the particles, but there are other gases that are associated pollutants with the smoke. And I just show you one example, but we measure on the order of 30, 40 different pollutants. It's just a summary of what we see, that pollutants that increase when this wildfire smoke hits us. The particles, PM10, PM2.5, that are smaller particles. Acetylene goes up 10 to 50 times. Ethene, which I showed you this example, goes up about 10 times. Benzene, which we're worried about, goes up 7 to 8 times. Hydrogen cyanide goes up 5 to 10 times, whereas other gases here actually don't. So there's certain pollutants that we see this enhancement in this wildfire smokes, but for many others, not methane doesn't look any higher. Nitrogen oxides, it's the same as always. So it really depends on which of these pollutants you're looking at. So now I want to just give you an overview of the work we've been doing. We're funded to do this monitoring, but then we work with the data and do science with it. We report it to the sponsors, to the public, to the media, to legislators, and we try to develop these peer-reviewed publications, which is a lot of work to get a paper published in a peer-reviewed journal. It's a huge effort. But that then, makes it undisputable science, sort of, mostly. Yeah. So once it's published in this way, it's hard to really disregard the results that are presented here from these different programs. So this is a really remarkable paper that we just published a few months ago. It's not quite in the front range, but that looked at pollution arising from the Suncor refinery in Commerce City. And we noticed quite significant increased levels of airborne radioactivity when air was transported through the refinery. So this was published, and this received a lot of attention. Just one slide that shows what we did. We monitored for a full year where this asterisk is here, a little bit north of the refinery. And then when we analyzed the data for the average concentration, depending on wind speed and wind direction, which is in these upper graphs here, the hotter the colors, the higher the concentrations. We have two different instruments. We saw that both for gas phase radioactivity, that's mostly radon, but also the radioactivity from particles that were trapped on filters. There were much higher levels when the winds were coming, from what you see here in that compass, which is exactly the direction of the refinery. So we did this year-long study, very clear indication that there's releases from this oil and refinery. But we've never done it at well sites. Nobody has done it in this state at well sites. If the refinery is a source of this radioactivity, it really poses the question, what's with these 25,000 plus well sites in the region? Do they emit radioactivity, and are people who live in the vicinity exposed to increased levels of radioactivity? Because we know, they emit, they release, they leak. We really don't know. It's one of the real big gaps in our knowledge, understanding of the pollutants that arise from oil and gas operations. This is really one of the very first steps. We had another paper that we worked on over a year, focusing on the data from the Boulder Reservoir, which is the longest running program. It's a huge paper. It's like 30-some pages, and I just want to give you a few snippets of what I think it's interesting. This is the abstract, and there's some numbers here. So NCFR stands for Northern Colorado Front Range Oil and Natural Gas VOC emissions of 183 gigagrams in 2015, and then in 2021. So we used these data to quantify how much VOC, what's the total mass of VOCs released in the Denver Julesburg Basin, what's upwind of the Boulder Reservoir. And then we compared that with what the state uses in its inventory, which mostly relies on the industry reporting of their own emissions. And when we compare that, we found that what we see in the data is about 2 to 2.5 times higher than what the industry reports and what the state uses in its assessment of the air pollution resulting from oil and gas, and factoring that into the model developments for assessing what it takes to achieve ozone attainment. This is a very, very important finding. It's more than, from the data, it looks like it's more than 2 times as much as what used in the regulatory framework. Now these numbers, very few people could have a sense for what's 183 gigagrams per year. So I did some math with that, just converted units, very, very simple. That's 300,000 tons of these VOCs per year. So that's roughly the weight of 40,000 passenger cars. Passenger cars about 2 tons, something like that. So that's the VOCs per year that we calculate are being released. That's equivalent to 600,000 barrels of oil. You can put a price on that, a cost on that. If you say, just take $75 per barrel, that's $45 million in oil that evaporates in the region. If you put this on these tanker trucks, it's 3,000 of these trucks. It would fill one of these oil tankers. And that's as much, how much VOCs every year end up in the atmosphere in the area. And that's, in these examples, we actually did not include ethane. If you add that, that's another 30%, and it doesn't include methane. And methane is about 3 times as much as all the VOCs. Methane is much more. So, multiply this by 3 roughly if you want to have the whole amount of hydrocarbons released, emitted in the air by the oil industry in the area. Okay, then we take the data and we can look at where's all these high levels from VOCs and methane coming from. We can plot that as a function of wind speed and wind direction. You saw that earlier for the refinery, and you can see if you sit here at the Boulder Reservoir, so these are data from the Boulder Reservoir, when wind blows across the basin, or mostly Weld County, you see clearly enhanced levels of these oil and gas tracers, whereas winds coming from the south, from Boulder, or the west, the mountains, or North Lyons, let's say, much, much lower concentrations. So on the side, we did another study, and this is a pure literature review. Just going through everything that's been published in the last 10 years. So top down versus bottom up. What that means again is bottom up is what's reported by the industry and used in these inventories, versus top down is based on measurements, which is what we're doing here, of comparison of reported, estimated versus really measured emissions, and reviewed the last 10 years of literature, and then tabulated this. There's a lot of data. You don't have the time to read this all, but this shows where these values fall in. I just showed you that for the Boulder Reservoir, you saw that it was 2 times higher reality than what's reported. So this line here, where it says 10 to the 0, that's 1. That would be if there was full agreement, 1 divided by the other. But most of these studies here are on the right, which means that the measured emissions are higher than the reported emissions or the inventory emissions. This is very, very consistent. What we see at the Boulder Reservoir data, is very similar to what's seen in many of these other studies in other areas where oil and gas emissions have been studied. So on average, if you average over all these data, the inventories underestimate actual methane emissions by a factor of 2.5. We said between 2 and 2.5 at the Boulder Reservoir. It fits right in, slam dunk with, what's been seen in other places around the country on average when you compare monitored, measured data versus reported data. Okay, then here's Another study that we submitted for publication that's currently in review. This is something really, really unusual. Didn't even think we could run into this. Usually we see high ozone in the summer, but here during, this was I think in 2000, we saw a very unusual high ozone event in March. In the top picture, you see the ozone recordings in 2020 and then 2021, and you see the high levels during the summer. And then here we saw this event in March. How can it be that we get this much ozone in March, this early in the season? Looking at the particles, we also saw that this was associated with extremely high particle. It was actually the most polluted day of the year, even from particles, exceeding some of the wildfire smoke occurrences in the prior year. Looking at this more closely, we saw that these high levels were mostly observed downwind of Weld County. You see these concentrations by the Scalar scale. So this is for ozone, but this is also for particle. So in this paper, we present the case that in these winter conditions, there was snow on the ground, and that enforces or strengthens surface inversions. So these emissions were trapped very close to the surface, and concentrations built up to much higher levels than we would get under non-snow conditions, and that then triggered this pollution event with high production of ozone, but also then very high levels of these particulates. Very, very interesting and unique situation. Linkage between, these relatively high emissions we have in the area and the suppressed mixing when we have winter conditions with snow on the ground. Working on another paper right now that may be of interest, significance for some of you who are trying to understand the exposure from operating wells and fracking operations in community settings. This builds on data we collected at the Broomville station. So what we observed there on the left side, that shows measurements of acetylene, which is another hydrocarbon, in Broomfield, which are the two green colors compared to the Boulder Reservoir and Longmont. And you can see that for several months, we had these very extreme high spikes over and over of higher acetylene at the two Broomfield sites. And then when we plot those against, again, wind speed and wind direction, it all came from one direction. And this monitoring site was right here where it says BLV. It was Broomfield Livingston. And if you go this direction of where the high acetylene is coming from, it gets you right to the Livingston pad. The Livingston pad, which sits between these neighborhoods of Anthem Ranch, Spruce Meadows, Wildgrass, sort of residential subdivisions in Broomfield. You can see the distances here. So this is an observation where we see these releases from, there was no fracking, that were producing well sites that were just producing all day after day after day. And we just through the monitoring program we had, both of these sites that were nearby, we saw these increases in pollutants. We reported them to Broomfield. They reported them to the operator, and within 2 or 3 days they changed something. We never figured out what it was, and that brought these emissions way down. So it's a very nice story demonstrating the benefit of having a monitoring program, because we identified these emissions, reported them back, and actually helped the operator to identify something in the operation of the site that they could then address and bring these emissions down. So now the last section of my presentation, I want to report on some trend analysis. Those are ongoing studies. And so trends, what we mean by trends is the change in time, concentration changes in time. We're looking at hey, is it levels going up or down? Is it getting worse or better? Is there more pollution or less? And I just want to show you a few examples of what we're doing. It's a huge program. We work on it a full year. I have 2 people doing this, and they're making hundreds of these graphs. So just a few snippets of it. So this is an example of methane. Below this, these are the data we've collected at these different sites, lots of them. And well, you can see, once you see that, well, at the Boulder Reservoir, it's actually pretty modest. These other monitoring sites, Longmont and Broomfield and Erie, you have these spikes every so often, and overall it looks higher, but you can't really see what are the changes. Is there any trend? So if we go in there in these data and select them and filter them and clean them, and this is just one of these examples. This shows then zoomed into this record, the methane record for the Boulder Reservoir, where we started monitoring in 2017. And we do this different smoothing, we apply these different smoothing algorithms. As many other pollutants, methane goes up and down every year with the season. And then we run a line, eventually, this yellow dotted line through the whole record. And that's our trend over this time window. We apply a linear trend, or we determine, if let's just call it linear increase, methane is going up. This is bad news. It's a very strong climate gas. It's going up. And this value here is the slope value that gives you the increase in parts per billion per year. So what we see at the Boulder Reservoir, it's gone up on average about 9 parts per billion per year over this time window. Then we do this for all the other sites. The blue one here, that's the Boulder Reservoir. Longmont started in 2020, and so that's here. And then the Broomfield sites and the Erie, and they all they're going up. Methane is going up. It's not surprising, because methane goes up. It's going up all around the world. What I added here as well is, for comparison, the methane record for Mauna Loa Observatory, which is in Hawaii, and that's used for following the global increase in the background area methane. It's right here in the center of the Pacific. There's no pollution sources anywhere close. It's a beautiful data set. So then if we now take these wiggle lines and run a linear trend through those, this is what we get. That's our best estimate for the increase in methane at these different locations. So at Mauna Loa, this is the one down here, what you see, there's about 150, 200 ppb less methane, because it's not surrounded by sources of pollution. Here in the Front Range, Boulder is the lowest, then Broomfield, Longmont, and then Erie is the highest in total levels on average. And then the slope values now allow us to compare the change in methane globally over this time window has been 12.2 parts per billion per year. Yeah, that's the slope of this line. Now, at these 5 sites we monitoring here, we have values of 7.6, 8.9, 7.9, 2, something like 2, which are actually lower. And this is a good piece of news. This is good. So the fact that the slopes here in the Front Range are lower than the global is an indication that these trends converge, which means that local pollution emissions here in our area appear to be going down. This is still very early. You need long measurements record to really bring down the uncertainties, these analysis. But all of these monitoring sites in the Front Range are lower. The slopes are lower than for Mauna Loa. So there's consistency. And this is actually direction I think we would want to like to see it. Indicating that there is probably decreasing emissions of methane. But methane is tricky. because methane is released from multiple sources. I have that here. Yes, oil and gas industry, but also dairy industries, wetlands, landfills. So if we see, methane going one way direction or another, we're not quite sure, which of these sources is determining this trend. So to get around this, we really like looking at ethane. Ethane is a much more selective tracer. Ethane, so it's a C2 hydrocarbon because it pretty much only comes from oil and gas. We don't need to worry if, how much did cattle or landfills contribute to the signal. We know this is pretty much oil and gas. So we pay a lot of attention to ethane. So this is the ethane record from the Boulder Reservoir, which is, as I said, the longest. And you can see these wiggles as the seasonal cycle again. It's larger in the winter, but then the blue fat line is the mean. And you can see, it really looks like it's dropping. It's been dropping over the years. The shaded is the standard deviation of the data, but overall the mean ethane seems to be going down. Yes, but really, if we just look at the last 3 years, it might well be it's flat. It hasn't really changed the last 3 years. It's only come down the first 4 years of the record, and then maybe it hasn't changed. So that's how complex this can be, trying to understand how these changes are. Fortunately, now we have these ethane observations, not just at the Boulder Reservoir, but also in Broomfield, in Erie, and in Longmont. And now those are the smooth seasonal cycles from all of these sites overlaid. You can see the Boulder Reservoir is overall the cleanest, has the lowest levels. Longmont in the winter is almost 2 to 3 times higher because it's closer to all these oil and gas sources. But you can also see these peaks are coming down in Longmont. They're coming down at the other locations. If we do this different statistical steps on it and look at the changes linearly over the records we have, they're all pointing down, and you can see all these slopes are negative. So there's been really a significant decrease in ethane. If we started here at a level of maybe 8.5, and now we are at 4 at the Boulder Reservoir. So it's almost dropped to half. So this is good. So these oil and gas emissions appear to be coming down. It's consistent between these different sites we are operating. So we have a pretty high confidence that what we're seeing here is pretty robust. There's one other compound. We have lots and lots of them, but many people are interested in benzene because it's such a harmful compound when we breathe it. And this is also good news, over this time period. It has decreased by about 10 parts per trillion per year. Doesn't sound much, but you do this over 7, 8 years, that's 80 parts per trillion, which brings it down from 130 parts per trillion to 80 parts per trillion, which is very significant. So, also benzene seems to be coming down. I think this monitoring data has been recognized by the community, by the agencies we reported to, but also by legislators. And I've been working with legislators on several occasions. And it's my belief that it has helped to direct some of these pollution regulations that we have implemented. And I would say what we see in the data reflects that some of these regulations have had a benefit on the air quality. We're probably not at the finish line, but I would say there's been some benefits from the program and these different parties working together. So that's the good news. The sobering news is, and you may have seen or heard this by now, that we were just informed that the program at the Boulder Reservoir has been terminated. It had been funded by Boulder County for 8 years in a row, and Boulder County decided to discontinue this monitoring. It's been in the news, and even Channel 9 News had it on on TV. We are, of course, very saddened, disappointed by it, especially, you know, I've shown you several examples, but the Boulder Reservoir record is the longest we have. And for doing this trend analysis, it's really the most meaningful, the most valuable, the statistically most significant data record we have to describe these changes in pollutants. And as of January 1st this year, there's no more Boulder Reservoir data. So, you know, this record very unfortunately comes to an end. And that's my last slide. And I hope you found something here that's of interest to you. And I'll be happy to answer any questions you may have.